In cryptography, you often have to raise a number to a really high power. And when you do that, you actually are interested in knowing the residue modulo some other number. It's really difficult to raise an integer to a really high power. So for example, if you plug in 5 to the 29th power in Wolfram Alpha, you're going to get this long number. Scientific notation, it's on the order of 10 to the 20th. So if you were to write a decimal approximation like 1.8626 times 10 to the 20, you'd be missing a lot of stuff. And this is a really big number. Like if you wanted to find out what's the residue of this mod 7 or mod 9 or mod 11 or something like that, and you worked with this number, that would be kind of a pain. And most calculators won't take things this far, to this many digits. So what we want to do is we want to reduce modulo n as we go. And we're going to use this exact example with a specific technique to efficiently and quickly raise an integer to a pretty high power. So our example is going to be 5 to the 29th power mod 11. Okay, so what do we do? It's this technique that's called repeated squaring. Okay, so we're going to take 29 and we're going to write it as a sum of powers of 2. What does that end up being? Well, reminding yourself of your powers of 2 will be very helpful. So 2 to the first power is 2, 2 squared is 4, 2 to the third power is 8, 2 to the fourth is 16, 2 to the fifth is 32. That's actually more than enough of what I need. Oh, I should also include 2 to the 0, which is 1. 2 to the fifth equaling 32 is more than what we need. So looks like we can write 29 as the sum of 16 plus some other stuff. So plus 8 plus, let's see, this 5 can be broken up into a 4 and a 1. All right, so consider exponent rules. If I write 29, this exponent, as 16 plus 8 plus 4 plus 1, that means 5 to that power is going to be the same as 5 to the 16th times 5 to the 8th times 5 to the 4th times 5 to the 5th. Now, we're going to use this method that I just said is called repeated squaring to finish this off. So we want to quickly calculate powers of 5 mod 11. Okay, so 5 to the first power is going to be 5. If we square that, we get 5 squared, which is 25. I'm going to subtract a convenient multiple of 11 from that. I'm going to subtract 22 and get 3. So 5 squared is going to be 3 mod 11. Instead of starting over and saying, okay, what's 5 to the fourth? Let me multiply 5 with itself 4 times. I can just take my answer for 5 squared, which is 3, and I can square that. So what would that be? This is the same as saying 3 squared. Remember, this is the mod 11 world. 3 squared is 9 mod 11. Okay? I know my equal signs are very informal right now, but it's okay. Let's go with it. 5 to the 8th will be the square of whatever we got for 5 to the 4th. So this will be 9 squared, which I could write that as 81 and then subtract a convenient power of, or a convenient multiple of 11. But notice that 9 in the mod 11 world is the same as negative 2. So what do I get when I square negative 2? I get 4. And 4 is between 0 and 10. So it's in that range that we want, that nice convenient range, small positive numbers. 5 to the 16th is the last power we need. So to do that, we take our answer for 5 to the 8th and we square it. In other words, we take 4 and we square it. 4 squared is 16. If I take away 11, which is my convenient multiple of 11 that I need, I get 5. So 5 to the 16th happens to be 5. All right. So then what happens now? Now that we've analyzed this, we've prepared ourselves for the repeated squaring method. So this is the result that we ended up getting. So instead of this 9 here, I should have changed it to a negative 2 at this step. Doesn't matter. The numbers are all still relatively easy to work with if you leave this a 9. But we'll go with the 5, the 3, the negative 2, the 4, and the 5. Now, which ones of these do we need? Well, remember, 29 is 16 plus 8 plus 4 plus 1. So we need the 16, the 8, the 4, and the 1. So we need just these 4 numbers. And we're multiplying these all together because remember, this is all multiplication. All right? Now, I want you to just do this as just a quick mental exercise. What is 5 times 4 times negative 2 times 5 mod 11? Do it one little bit at a time. 5 times 4 is what? Kick it down to something between 0 and 10 by subtracting an appropriate multiple of 11. Whatever that is, multiply it by negative 2, kick it down or kick it up, and then that result, multiply it by 5. Keep the numbers small. That's what modular arithmetic allows you to do. Keeping the numbers small so that the calculations are easier to do. Anyway, it turns out that if you do that with this, you'll get 9 as the result. So 5 to the 29th power, which was that huge 20-digit number, is congruent to 9 mod 11. As an exercise starting from scratch, go ahead and use this repeated squaring method to find 7 to the 45 mod 11. And once you're done with that, try another example, which is 9 to the 58th power mod 23.